All right. At this video, we're going to talk about uh, kind of problems in linear equation. You know, here, what are these? Distance is equal rate times time. Means that if you if for example 200 kilometer the distance, you know, the unit of distance is, I talked about it here, it could be kilometer, meter, centimeter or millimeter or mile, foot, inch. And now we talk about these. These are the unit of distance. Now, if we show it graphically, the x-axis, y-axis, x-axis, y-axis. X-axis is time, t. This t could be hour, minute, second. We usually use those hours, minute, and second. And distance, as I said, like kilometer, meter, centimeter. If you have here kilometer and here is hour, if you have a graph like this, for example, the equation of the linear equation, you know, y is equal to mx plus y0, or some people say the constant. Actually, it's the constant is this much here, like a car start, somebody is going to start driving, and from here to here, A to B, it's already gone 10 kilometers. So this is 10. It's actually y 0 or constant. And then with some rate is going to show that the slope of this one, the kilometer per hour, or could be meter per second. See, if you get the slope of this, like this is y and delta x. We talked about it earlier, that if you want to find the slope of that, like for example here is 10, is 20, talk about meter. This is meter and meter vertical axis and second horizontal axis. And here was 1, 2, 3. 3 seconds. So we say velocity is the slope or the rate of the change of the distance to second. See, if it's meter and this is second, it's going to be, the unit is going to be meter per second. So if the distance is 20 meters, for example, here, the rate of the change is going to be 20 minus 10 is delta y. 20 minus 10 is going to be 10 meter. And then the delta x from 3 to 0 here. So delta y delta x is going to be 3, actually minus 0 here. It's going to be 3 seconds. So the velocity is going to be 10 meter per 3 seconds. It's going to be 3.33 meter per second. So the slope actually is going to tell us that how this is going to change, the rate of the change. I give you some practical example. If you say the rate is 80, if the rate or the velocity here is 80 mile per hour, and it takes about 3 hours. You want to find the distance. What is that? A car or a vehicle going 80 miles per hour, and in 3 hours, how many the distance is going to be? The distance is going to be velocity times t, or the rate, r. Here is 80 mile per hour times 3 hours. So this cancels out. It's going to be 240 miles. In 3 hours, it's going to go 240 miles. We show it with mi, mile. Or if a car has the distance they traveled 240 kilometer, for example, and the rate you want to find in 2 hours distance, the time, 2 hours. You want to find the rate or the velocity. Velocity is distance divided by time, t, and 240 divided by 2, 120. What's going to be? Kilometer per hour. So these are the things that, just to show you that the relation of the velocity, and also talk about the time. What is time? Time is going to be distance divided by the rate, or the velocity here, velocity. It's going to be like if a car got 300 miles in rate of 50 this is mile, and it did 50 miles per hour. It's going to be 6 hours. It's going to take 6 hours. You know, mile with mile cancels out, and if it travels 300 miles with the rate, the velocity is 50 miles per hour, so it's going to take 6 hours. Now get to some practical example. The unit of distance. Now suppose that a car travels 200 car travels 200 kilometer. Okay, and the rate, the time is going to take let's talk about more complicated. I was gonna talk about. See, there are two cars. Car A, car B. Start from here, go to somewhere. With this one travels 70 miles. For example, mile. We talk about mile here, the distance. And the other one travel 100 miles. But they will get to the point, to the end point at the same time. Like for example, we talk about the t that the time takes to get to the final destination. This one was 75 miles, but car, let me exactly talk about this example that I'm talking about. This car A and car B. Okay, the distance and the rate or the velocity, and then we have time, t. See, look at this, and the time. See, the distance, car A is going 200 miles, and the second one is going 100, the distance is 100 miles. But at the same time, they spend the same time, like we say that this one is going at the rate of x, for example, at the velocity, like 20 miles per hour, 50 miles per hour, whatever. This car is going faster. The rate of this one is 100, and the rate of this one, the distance that travels is 100 miles, and the velocity is x, or the rate is mile per hour. This is mile, and the distance is hour. And this one that has gone 200 miles, at the same time they have reached to a point. This one is travel 20 miles per hour faster than this one. Now you are going to find out what is the rate of these two cars. What were the velocity? They have reached at the same time. The t is equal. So the time is going to be velocity, distance divided by velocity, and it is give like here hour. This is mile, and this is mile per hour. So if you divide this one, if they reach the point at this at the same time, we are going to find out what is going to be the rate, what was the velocity was. So from this formula, I say the distance, x is the distance, okay, and this is the velocity here. So actually it's going to be 200 the time. You're going to talk about time. X plus 20, and this is 100 mile gone with the divided by the rate, but the velocity, they reach they spend at the same time. I mean the time was equal. They traveled somewhere, the distance was 200, but this one is going faster, and this one was going with 100 miles, traveled 100 miles, it is slower than this one. So if we set these two equal, to each other, you see 200, their t is equal the same, t. We set these two equal, we are going to find out the rate. What was the velocity of each car? 200 divided x plus 20 is equal 100x. And then if you solve this one, 200x is equal 100x plus 2000, right? Because we multiply this one by this one, 200x, and this one by this one, 100x plus 2000. Now we are going to find x. 200x minus 100x is bring here, change its sign, equal 2000. And it's going to be 100x is equal 2000. X is going to be 200, 2000 divided by 100. But it's going to be what? It's going to be 20. So actually 20 mile, we're going to talk about mile. 20 mile, x is going to be 20 mile. So x, the car B is going to 20 mile per hour, but this car A was going, car A is 20 mile per hour, and car A, this car B, okay, and car A is going to be 20 plus 20, x is 20, right? It's going to be 40. It's 40 mile per hour. This was going 40 mile per hour, and the other one 20 mile per hour. So this is one of the problems that using like linear equation, using the rational function. We can give you one more example of that. Another example, we talk about it now. So suppose that this time the rate is going to be unknown. This is rate or velocity. This is time, and this is distance. What is distance? Distance is equal to rate times time. Mean velocity times t. X is equal to vt. So because this is like, suppose that this one we're talking about is kilometer per hour, or anything can be meter per second. For example, let's talk about this time now. Meter per second times t, the second. These are cancelled out and it's going to be meter. So this we are going to find the rate. You know, there are two cars going toward each other. Okay? And the distance between them is 480 miles. 480 meters. I'm sorry. This is car A and car B. You're going toward each other. The distance is 480 miles. So the time it takes, we are going to find that, you know, at t is equal to 4, at t is equal to 4 second, for example, they with the same time they reach each other. So we say that this car A, the rate of this one is x, we don't know, and the rate of this one is y. But the time, oops, x and y, the time for all of them is 4 seconds. The rate here is meter per second, and the distance is going to be meter, and this is second. So we say the distance this was is 4x, and one of the thing is one of the things we got to know that x, the car A, the rate, y minus, for example, 10 means the rate of this car is traveling is like 10 meter per second is less than y, means slower. So we have 4x, 4y, and then what we do, we say x, so x, we know that x plus y, 4x, plus 4y, the total distance was 480 meter. So it's going to be, this one is 480 meter, okay? And we are going to find out what the rate of each car is. We know that car A is going slower, 10 meter per second is slower than the car B. So if we find x is equal to y, we put x, y minus 10 plus 4y is equal to 480. It was 480. 480. Okay. Now we are going to find the rate of this y. You know, we use this formula here to get the distance they travel. We reach the point at the same time. You know, the distance we said this. See, no, the distance we say we get it. The rate x with times 4x, the distance is travel, and this one with 4 seconds, with the rate of y, travel y. And then altogether 4x plus 4y is 480 miles. So it's going to be 4y minus 40 plus 4y is going to be 480. It's going to be 8y is equal 440, and you divide this 440 divided by 8 is going to be 55. Y is going to be 55. See, 55 meters per second. This is going, the rate, we find out the rate is 55 miles per second, and x, if we are going to find x, we said that x is equal to y minus 10, because it's going 10 meters per second is less than the car B. Okay? And then you say that x is going to be 55 minus 10 is going to be 45. 45 miles per second. So these are the problems that you see in work problem using distance, velocity, and time to show you that all these linear equations, and we can find some of the unknowns through this subject. So just remember that whenever x and y, whatever, this one I said like could be feet, and this is could be second. So if you find the slope of this one, delta y, delta x, you find that velocity, which is delta y divided by delta x, means change of y. Like this is 100, this is 4, for example. It's going to be delta y 0, 100, or minus 100 minus 0, and this one 4 minus 0 is going to be 25. So it's going to be, if it's feet in second, it's going to be 25 feet per second. So whatever this could be, a typewriter can type like 50 words per minute. If you see word per minute, this is word, this is minute, okay? And the slope is going to be word, this one, word per minute. Okay? So whatever this vertical axis is, and whatever the horizontal axis is, this way we can find the slope.